Okay, so what we're talking about in partial fractions, we're going to take a fraction that's p of x over q of x, where p of x is a polynomial and q of x is a polynomial, and q of x has non-repeated, in this case, q of x has non-repeated linear factors, and the degree of p of x is less than q of x. And so in that case, you can break it down into some number over the linear factor, another number over another linear factor. This actually should be a 2 here. Looking at that, that should have been a 2. There we go. So the point is, these are different linear factors on the denominator, and then you have the different, I mean, they happen to be the same in the numerator. It could be a 1 and a 1, but it isn't necessarily the same. And the point is that it breaks down into these simpler type of fractions. It's a really neat process. So let's go through this. Use a variable for the original numerator, usually a, b, or c, depending on the numerator number of factors, placing each variable over a single factor. For the purpose of this definition, we use a sub n for each numerator. So p of x over q of x would be like a1 over a sub 1 x plus b1 plus a2 over a sub 2. Again, got to fix that one. X b2 plus dot dot dot, so on. Multiply both sides of the equation by the common denominator to eliminate the fractions. Expand the right side of the equation and collect all like terms. Set coefficients of like terms from the left side of the equation equal to those on the right side to create a system of equations to solve for the numerators. And so that's why we needed to know about systems of equations, so we can actually do this. So here's one. It's kind of cool. 3 times x over x plus 2 times x minus 1. So we're going to write this as, think of this as 3x over x plus 2 times x minus 1 equals something like a over x plus 2 plus b over x minus 1. And the next step is to clear out the denominator. So we're going to multiply everything by x plus 2 times x minus 1 times the 3x over x plus 2 times x minus 1 equals, we have x plus 2 times x minus 1 times a over x plus 2 plus b over x minus 1 times x plus 2 times x minus 1. And this has the effect of the x plus 2's dividing out, the x minus 1's dividing out, which is what we expect because we're multiplying to clear it, so we can get that 3 by itself. Then over here, the x plus 2's divide out, the x minus 1's divide out. And so it gives us 3x on the left equals, we have x minus 1 times a, so ax minus a, then plus, so we have b times x plus 2, bx plus 2b. Now, look at this. It's kind of interesting. On the left here, I don't see a constant. So if we had on the constants, I don't know why that changed on me. Oh, my pencil die? Okay, on the constants, on the left I have 0, there's no constant. But on the right I have negative a plus 2b. So a must equal 2b. Okay, so if we find b, then we can substitute for a, and we can also use that to substitute in the second equation. So for our x coefficient, we have 3 on the left, and on the right we have a plus b. Okay, so if 3 is a plus b and a is 2b, I could take 2b and put it in place of the a. So I have 3 equals 2b plus b. So 3 equals 3b so b must be 1. And if a is 2b, a must be 2 times 1, which is 2. So that 3x over x plus 2 times x minus 1 must equal a, which was 2, over x plus 2, plus b, which is 1, over x minus 1. And we've decomposed that fraction.